Told you. Leaving up the final exam week. Why is it that their default sound for starting a recording sounds like somebody loading a pistol? Ay. So, last time we were having some struggles at the end of class, writing something to a file. We were getting it to write to the file, but we weren't successfully adding stuff to the file, if you remember correctly. So what I'm going to do here is we're going to make it work this way. I'm going to show you a better way of doing it. So we're using our scanner to read stuff in from a file. So what I'm going to do here is I'm going to create a string array called lines. This guy's going to be a new string array, and let's just make it size 10,000 for right now, just for our little example. And I'm going to say int count, start that off at 0. All right, now, so right now we're opening up the file for reading, our mydata.txt. We'll read everything in from it. I want to read it in to lines. So I'm going to say lines let me actually say pause is equal to we need pause, we can just use count. Okay. So we'll say lines at bucket count is equal to input dot next line. So we'll read in a line, store it inside of our array, and then we need to say count plus plus. So we're going to fill up our array of strings with all the lines of code that are lines of text that are currently in our file. All right. Then I'll say input dot close to write it back to disk. This line's probably not necessary, but for historical completeness, this is never wrong. When you're done using a file, it's never wrong to close it. Okay. Then I'm going to open the file for writing. And what I'm going to do is I'm going to create a for loop for int I is equal to 0, I is less than count, I plus plus, and I'll say file out dot println lines at bucket I. So I'll write all the current lines back to the file that I read in. And then I'll write an extra line, that blah 17 at the end, and ultimately close the file. This makes sense? So I'll read in the file for reading, read all the lines of the file, up to 10,000 of them, into our array called lines. Then open up the file, write all those lines back out, following the final extra line we want to put in there. That makes sense? So quickly, let me go to the file system. And let's look at our this is called string test. String test. So it's not in there, it must be in here. So here's our mydata.txt. So right now it just says blah 16 in it. So the hope is once we run this again, we should have blah 16, blah 17 in that file. Ran it. open up the file, blah 16, blah 17. Come in here, let's throw an 18 in there. Run it again. Blah 16, 17, 18. Okay, so it's doing what we want it to do, but we're having to kind of manually pull this off. Now, before we talk about a better way of doing it, a more better way of doing it, and then I'll mention the most bestest way of doing it. So before we talk about that, what's the biggest weakness of this code? Another late straggler. Hold on. Which is the 35-second one. Here we go.
Suck on this, you furry little weirdos! Enough of this crap! Ezekiel!
I should probably just leave that up in a tab just in case. All right, so again, what's the weakness of this right now? Or what's the greatest weakness? We can probably come up with a couple of weaknesses. What would you say the greatest weakness is? Go ahead.
You're limited to 10,000 lines.
Can't read in files greater than 10,000 lines. Realistically speaking, is that going to be a problem very often? Probably not. But that's actually pointing out a weakness of arrays in general. And that's a problem that we solve next semester in the data structures class, where we introduce initially something called a linked list, which is think of it from our perspective now, an expandable array. It's a little bit more than that, but so we would start it off as empty, and then we can just add an arbitrary number of lines to it, and it would just keep getting bigger and bigger and bigger. Right now, if we want to do that, we have to keep building a brand new array. Correct? So, pretty inefficient. The other thing we might say here is that this is fairly inefficient. File I/O is actually pretty expensive. I think I previously in this during the semester, I showed some example where we tried to print something out to the screen a zillion times, and it really slowed down, maybe a for loop that went through a million times, and if we don't print anything, it goes really fast. But if we print something, it takes 7 or 8 seconds for it to actually run, maybe even longer than that for a million. We saw that, right?
It took a really long time.
Okay, so the idea is that I/O in general, input-output in general, is expensive. Okay, because there's something called an interrupt, where in order to display something to the screen, your processor has to pause so that the current guy on our current program leaves the processor, goes and writes to the screen, then gets back in line to get more processor time. It's an operating systems concept. So the point here is that file I/O is even slower, because with screen I/O, we're actually writing from memory out to the screen. Where file I/O, we have to read from disk first, then write from memory out to the screen. Well, write from memory back to memory, then back to disk. Does that make sense? So it's even slower. So file I/O is probably about as inefficient as we can get in a program. In our program like this, it didn't make any difference. We have 3 lines we're reading it. We didn't even notice. But it is pretty inefficient, and will just get more and more inefficient as we move to bigger lines. Now, there's a class, or bigger files rather. In Java.io, there's a class called File Writer and File Reader. We already have a good way of reading with our scanner, but we'll look at File Writer here. File Writer is an output stream writer, which is a writer, which is an object. And this is actually going to become a little bit important today because we're going to talk about inheritance. So we can create a file writer, giving it its file name. And then there's a second, remember I was trying to come up with this last time, there's a second parameter that allows us to append. So what we're going to do in our code is we'll comment out this line, get rid of our array. Basically, I'm reverting it back to where we were before. Actually, we don't even need to be able to read it in. We're confident that we can confidently read a file in, so let's just get rid of that. We just want to prove that we can append to a file. So rather than a print stream, actually I need the name of my file here. It's mydata.txt. I'm just going to steal that. Rather than a print stream, we're going to create a file writer. It's called output. This guy's going to be a new file writer, passing it the name of my file as well as true. I want to be able to append to this file. All right. File writer, we need to import, so we'll import java.io.filewriter. All right. And now what we'll do is we're just going to say output dot. Is there a? I guess we'll do append. Output.append. Blah, let's just start with 20 because I don't remember where we left off. Oh, did we? We left off at 19? Epic. All right. And then we'll say output.close. We'll go ahead and run this. Let me make sure this guy is, let me just close that for right now. Okay, go and open it up, and there's our blah 20. It was only 18. In your code, it was 19, wasn't it?
But I meant 19, whatever.
Oh, 19 is the next one we should have done.
Yeah.
I gotcha. That's how you know this is more better. This is a new one. I wanted to designate that this is a new way of doing it. So we saw this added a new thing, right? Okay, now I'm going to add 21 now. But notice where the 21 goes. Right at the end of that line. So we're actually not, when we do a println, when we're just displaying to the screen, if we say system.out.println, what's happening? We write something to the screen, and then it's like we pressed enter. Carriage return line feed, right? Well, if we want that to happen inside of our file, we need to include a carriage return line feed. So we have some escape characters. So I'll go ahead and write my 22 here, but then I'm going to put in \n. \n represents a carriage return. And so we'll see this work here first, and then I'm going to talk a little bit about this. So \n, we'll write this. It'll still be at the end of the previous line, because the previous line we didn't write the \n on. So we'll open it. We'll see that everything's still on one line. Okay. Now, I'll run this again, though, with our 23. And we'll see this guy's now on a next line down because of the \n. That makes sense? So now we get to a little bit of a weird incompatibility thing. This is less of an issue today, but maybe you've seen this before. Have you ever opened up a text file on Windows and seen, or even on a Mac, but it would be more common on Windows in Notepad, specifically in Notepad, and seen at the end of what should have been an end of a line, it had like a square, and it was just everything all in one big long line, wrapped with line wrapping? Kind of know what I'm talking about? Some of you have seen this before? It's because Notepad recognizes end of line differently than a lot of other programs do end of line. \n is the carriage return symbol. It's a unit. It's an ASCII symbol, but it's the carriage return symbol. And most text editors, notice that as carriage return plus a line feed. Okay, actually I'm lying. \n is a line feed. So most text editors interpret that as a carriage return, pressing enter and feeding it down one line, moving down to the next line. Notepad does not. Notepad actually requires us to issue both commands. That is a carriage return, then a line feed. Okay, so I'll run this for 24. And I'll run it again immediately for 25. Okay, and we see it still works fine on other text editors. So the foolproof way of doing this, if you ever do file I/O, it's a pretty rare thing anymore, which is kind of sad, but we're moving away from it, is to always do a carriage return \r and then a line feed \n. That will always work. Notepad, but let's just say everything that I'm aware of except Notepad, I'm sure there's some other programs, but everything I'm aware of except Notepad will recognize just \n as the equivalent. Notepad likes them both. Okay, so that's how we can write things, add things to a file, as with a file writer. Make sense? But you have to specifically build that file writer with this second parameter set to true. If we set it to false, or we don't even use it, we can use the one that just takes in the file name, because I think the default is false. So let's do that real quick. We should get a file with just a 25 in it, I believe. So all our hard work is now gone, because we chose to build it in non-append mode. So the default constructor for file writer that just takes the file name is equivalent to the constructor that takes the file name and false as the second parameter as to whether or not we want to append. And I'll prove that by doing a 26. And we'll see that this guy works the same way. That make sense? Okay. Now, we know how to do a little bit of file I/O, writing stuff to a file and reading stuff in from a file. Now remember our customer record. What's a customer record? A customer record has a first name, a last name, an email, and a phone. Well, we can represent this data in some sort of interesting way. Maybe we represent it as a comma delimited list. That might be an interesting way. So what I'm going to do is I'm going to get rid, well, I'll leave the display for right now. Basically what we want to be able to do is we want to be able to write customer records to a file and then read customer records back in from a file. But our issue is that a file doesn't know how to handle objects. A text file doesn't know how to handle objects. So we're going to have to figure out how do we represent our objects, our customer record objects, inside of a file. We might choose to represent this guy inside of our files, maybe Mike, comma, Littman, comma, Mike at awesomefat.com. And I must not have, I zigged when I should have zagged. There. And what's the last one? Phone number? Like that. We might choose to represent a customer record that way, delimited by commas. Make sense? Okay. So we need to create ourselves a method for creating that to storage string, let's call that. So we'll call it public string to storage string. And this guy's going to do a system. Actually, we're going to create a new string. String answer starts off as the empty string, and we'll say answer. Actually, we should start it off with our first name. Then answer plus equals, well, let's just do it a little bit longer. Answer equals answer concatenated with a comma concatenated with this dot last name. And I'll put this dot on this guy just for consistency. Similarly, answer equals answer this dot email. Answer equals answer this dot phone. And then ultimately return answer. Make sense? Now remember, a customer record we build with these 4 pieces of information. So I'll go back to driver. Let's just get rid of all this crap for right now. And I'm going to create a customer record, CR, and this is going to be a new customer record. Is the next one email or is the next one phone? Email. All right, so we'll build our customer record like that. Minimize this guy. And then I'll say cr.display, which shows it for human eyes, and then I'll also then do a system.out.println cr.to storage string. And we run this and we see here's our pretty print version, and then here is our storage string, comma delimited. That makes sense? Okay. Now, we probably want to be able to build a customer record from a storage string as well. Make sense? Because we might be reading in from a file something that looks like Mike, comma, Littman, comma, blah, blah, blah. So I need to create a second version of my constructor. Public customer record. And this guy's going to take in a storage string as a parameter. And we need to set our 4 variables based on what that storage string is. How do I, if I have a storage string that's a comma delimited list of my piece of information, how do I get those 4 pieces of information out of there? What are my options based on what we know? You use string tokenizer. Anything else? So all we know?
For loop until we get to a comma.
Okay, we can build our own parser. We've done that. This is when we were doing that process expression. Remember we did the math expressions? So we can do that, then we can use a string tokenizer. Now I'm going to show you a third way, probably the most convenient way of doing this. I'm going to create a string array called the parts. And this guy is going to be equal to storage string dot split on a comma. And what that gives us is it gives us an array called the parts filled up with our 4 pieces, everything separated by commas. What it doesn't give us is that, and actually is there a version of split that gives us the, there's not. So we don't have a version of split that will give us the tokens as well. the delimiters. So we can't get the commas using split. We'd have to use a tokenizer for that. But this will work just fine for what we want. So then we can say this dot fname is equal to the parts at bucket 0. This dot lname is the parts at bucket 1. This dot email, excuse the copy, the parts at bucket 2. And this dot phone, it's the parts at bucket 3. Make sense? So now I have two separate ways of creating a customer record. I can pass it 4 individual pieces of information, or I can pass it a storage string and it knows how to split it up. What's it called when we have 2 method-like things with the same name but a different number and or type of parameters? Polymorphism. All right, so what we should be able to do out here then is I should be able to create a second customer record, CR2, and this guy's going to be a new customer record, but we're going to pass it a storage string. What storage string? We'll pass it CR to storage string. All right, so I built CR first, passing it my 4 piece of information. Then I built CR2, passing it the storage string version of CR. So I should really have 2 identical customers now, right? But they were built in 2 different ways. So now I should be able to say cr.display and cr2.display, and they should both show the same thing. So there's the first one, and there's the second one. Make sense? Okay. Now, so I know how to build a customer record now from a storage string. I need to be able to store a customer record into our file. Every single time I build a customer record, for our little example here, we want to go ahead and get it to store in our file, right to the file, right? Now we remember our file's name is mydata.txt. So just for a starting point here, I'm going to go ahead and, oh, I did already empty out, good. We're going to teach a customer record how to write itself to a file. So I'm going to come into customer record, and we're going to write a method in here, public void, well actually here I'll put it after the constructors. You don't have to, but that makes more logical sense, I think. Public void store record. Okay, so I'll make this guy called store record, and his job is to write this particular record, this guy, to our file. So we're going to need our try, and we'll create a file writer called output. This guy will be a new file writer, mydata.txt. Was it a capital M? No, lowercase m. mydata.txt, as well as true for appending. Okay? Now it's going to want me to import our file writer from java.io. Then I want to write to that file the storage string version of this guy. So I'll say output dot append this dot to storage string concatenated with \n to kick it down the line. And then ultimately output.close to write the file back to disk. Something goes wrong, we'll just catch a random exception E and do nothing right now, just because we're lazy. Actually, the even lazier version of this, if you don't want to deal with tries and catches, is to say our store record throws an exception. If you say this in there, you don't even have to use a try catch. Because what throws exception says is, I don't want to deal with it, let whoever called me deal with it. Well, chances are we probably called it from within our main method here. So if we didn't want to have to deal with it in here, we have to say throws exception here, which throws it up to the Java virtual machine. So we can keep throwing errors up the stack until we finally get to a point where it's not our problem anymore. Kind of defeats the purpose of exceptions, since the point of exceptions is that it allows us to gracefully deal with errors, file not found errors, array index out of bounds errors, things like that. So it allows us to try to do something, catch a problem if it occurs, and deal with it programmatically rather than just have our program crash with red text. The red text is what happens if something gets thrown all the way back up to the Java virtual machine. It spits out the error in all red text and says, fix this. Okay, so this is the lazy way of doing this, which I would say is relatively acceptable when you're writing little utility applications where you know, like for instance, one exception that can occur that they don't force you to try and catch is with integer.parseInt. Like for instance, if I say integer.parseInt Mike, I try to turn the string Mike into an integer, doesn't make a whole lot of sense, right? Well, it's going to scream. It's going to say number format exception. Can't do that. Well, if we are using integer.parseInt to solve a problem, and we happen to know that we're never going to give it something crappy, we can choose to throw any exceptions that we get. Integer.parseInt's a little bit of a bad example since they don't force you to try to catch that exception. It's not a required exception to catch. But these things with the file writers and stuff are. If you happen to know that the file that you're opening is there, I know that my data.txt is there. I don't have to worry about that. Okay? So, with that in mind, why write some specific code when I can just throw the buck? Pass the buck. But, just a couple different options for dealing with exceptions. The programmatically competent programmer version of this would be, a correct way of doing this would be to do a try catch and handle it yourself. Clean up your own messes, so to speak. Okay? So, store record. If we tell a customer record to store itself, it'll create a new file writer. It'll write the to-storage string version of itself to that file, along with a \n for a carriage return. Then it will close that file. All right. So right now my file's empty because I had just emptied it. And so I'll go ahead and run this program real quick, and we'll prove that the file is currently empty. Okay, so there's my file, nothing in it. But now we've created two customer records, and let's just decide that now is an appropriate time to store them. So we'll say CR, go ahead and store yourself. CR2, also go ahead and store yourself. So we'll tell both records to store themselves. Hit play, go and check our file, and we see that both records have stored themselves in the file. That make sense? Now, the code we use for writing things out didn't change. I mean, it's still not complex code, but it's still, it'll be annoying code if we have to write it over and over again. But what we did is we modularized it. We encapsulated it inside of an object, specifically inside of a method inside of an object called store record. And all we have to do if we have a customer record is tell it to store itself. And since we already wrote this logic once, it stores itself. And we don't have to see it. So main looks easy. Create a couple customer records, tell each one to store itself. Done. That's what main looks like. So object-oriented programming, one of the goals of it should be to have a very, very clean main. Okay? Main should literally look like our algorithm, the solution to the problem. Do this, then do this, then do this. And all the details should be hidden inside of our objects. This goes back to the difference between procedural programming and object-oriented programming that we talked about probably the first week of class. And I was talking about the telephone on the desk over here. When we had everything in main, that's when we see all the wires. When we hide the stuff inside of a customer record object, that's like putting it inside of the telephone enclosure. That make sense? Okay. Now that I have some records in there, and actually let me, well, I guess it doesn't matter. We'll just read them in. So now let's say we want our program to read in some customer records. Okay? Well, that means if my file currently looks like this, I need to read from my file as many lines as I can and get that file, or get each line and turn it into a customer record. Correct? So how do I read in from a file? I use scanner. Input is equal to new scanner. And the scanner I'm going to create is, let's see, what was it, a new input stream? From my file.txt.
Data.
Oh, my file.dat. Oh, my data.txt. Like that? Okay. We'll go ahead and input. I'm thinking it's unlikely that this is the line we used because there's probably a version of scanner that just takes in a file name, would be my guess. I'll just look real quick. It's in java.util. What I have written there will work, but I bet you one of the constructors for scanner just takes in a file name. And it does. Yeah, path. Okay. So I actually only need the file name here. All right, and then I'll say while input dot has next. I'll go ahead and I'll say system dot out dot println input dot next line. So we'll write it to the screen. We'll read from that file, we'll write it out to the screen. Make sense? So we should get 2 lines written to the screen. Oh, what did I do? My data.txt.
I think we ran into the same issue.
Yeah, we did. We did. Oh, do we even ever fix it? We just kept checking the
I
file.
think we moved down.
Okay. So here, let me fix it real quick then. Well, screw it. Let's just use a file reader. File reader allows us to read in what at a time? Oh, perfect. Okay. So we'll use the complementary class to file writer called file reader. And this guy requires a try catch, so we'll just take a bailout approach and throw the exception up here. So here's an example of the lazy man way of doing it, because I don't want to have to write the try catch in here, so I just decided to throw the exception I might get. So we're going to create our scanner, call input. We're going to build it using a new file reader for that, the name of our file. And then as long as that guy has more stuff, we should be able to print out the lines, and I think this should work. Okay, so we have our lines printing out now, right? Okay, so now we at least have a compatibility between the two sides, where to write stuff we're using our file writer, to read stuff we're using scanner in conjunction with our file reader. What does scanner let us do? It lets us read things in one string at a time, where a file reader alone will let us read things in one character at a time. So you'll see we have methods like read. And the read method literally reads in, well, here's one that reads in a single char. It'll come in as an int because it'll be the Unicode character, but it'll read in that file one char at a time. Okay? Not that convenient for us. We like to read things in as strings because Java is a string-based language. So that's why we used a scanner to read stuff in from this, because it allows us to read stuff in with the readLine method one string at a time. Okay? So we've proven that we can now read in from that file, but now I want to create customer record objects. How do I create a customer record object? By reading in from that file. What's the contents of my file? Contents of my file is customer records. Right? Those are customer record storage strings. Can I build customer records using a customer record storage string? I can. So we'll go ahead and just for our quick little example here, I happen to know we only have two of them. So I'll say customer record array. The records is equal to a new customer record 2. And I'll say int pause is equal to 0. And what we'll do is we'll say the records at position pause is equal to a new customer record built using input dot new customer record inputs right here. Oh, it's not called read line, it's called next line. There we go. So I'll read in each line from my file, which is a storage string, and send it to my constructor for customer record. Make sense? All right. And then put that customer record that's created into my array. Finally, I'll print out my customer records for int I is equal to 0. I is less than the records dot length I plus plus. And what will we do in here? We're going to go ahead and just say the records at bucket I, which is a customer record, dot display. So we'll tell each of those records to display themselves. They happen to be the same record, but oh, actually, this will be interesting. The reason that happened is because I printed out carriage returns. So actually, I went through this loop one extra time because I had a line with nothing on it. I had an empty string line. That is a line that doesn't have anything in it. That make sense? And I tried to start accessing bucket 0, bucket 1, things like that from something that was not delimited by commas. So here, quick little fix for that, because I need to move on to something. I'll say string temp. Temp is equal to input dot readline. I'll ultimately do temp in here, but I'm only going to do that if temp dot length is not equal to 0. And I hope a string that just has \n in it is not equal to 0. So if this still crashes, then I have a secondary fix. Still crashes, okay. If temp dot equals well, it shouldn't be let's see if we're going through here 2 or 3 times. Okay, we actually only went through 2 times. So the problem was not that we read in an extra carriage return. The problem instead is in the constructor say input dot next line dot trim. I think that fixes it. So trim doesn't get the well, here, I can show it real quick here. Oh, that's not going to fix it. The problem is that first line has that \n at the end of it for it to look nice from a human readable perspective, but it doesn't look, it has an extra character in it for our parser here. So I'll say int I or int pos is equal to storage string dot index of the \n character. Let's find where that guy is. And then I'll say if pos is equal to -1, which means, or if it's not equal to -1, which means there is a \n there. Then what I want to do is I want to say storage string is equal to storage string dot substring 0 to pos, and it won't include pos. I think that should fix it. Hey. So creating that first storage string, creating that second storage string, writing the first guy. So we were able to display the first guy. Which is this. Oh, I just wrote bad code.
What?
Inconceivable.
Debug that. What did I write poorly there? I'll give you a hint. It's in the while loop. And as always, I did it on purpose. I was testing you. Nobody sees it yet? How many records am I reading in? 2, right? Where am I putting the first record? Bucket 0. Where am I putting the second record?
Bucket 0.
I'm never changing pause. So when I try to print out the customer record at bucket 1 down here, it's not finding crap. And it's yelling at me because it's, look, you are trying to call a display method on a customer record that's not there. So it would behoove me to increment pause as I'm filling up that guy there. I can take all of this crap out of here. And now we have something that works. Does that make sense what the problem was? I wrote both customer records to bucket 0, no customer record to bucket 1, and then tried to print out the customer record from bucket 1, which is going to end badly. All right, questions about that? Okay, now I'm actually going to create another class. I need to show you one additional thing to kind of complete this course. So I'm going to create a class here called checker. So I need to make this super simple for time. All right, so think about like a game of checkers. Checkers are little circular game pieces. They come in 2 flavors, red and black, typically, right? Okay, so a checker has a color. So that's a piece of information we'll keep track for a checker, just its color. All right, and we will say public checker. We'll take in a string color as a parameter, and we'll set this dot color equal to whatever color was read in. Make sense? Nice, simple little object. Call checker, keeps track of one piece of information, color, and gives us the ability to build it with a color. Okay? So we'll go back out here to driver. I'm going to get rid of all this crap because we're on to a new example here. And I'm going to go ahead and create a couple of checkers. Checker C1 is equal to new checker red. Checker C2 is equal to new checker black. Okay. And let's go ahead and teach our checkers how to display themselves just for the heck of it. Public void display system.out.println a concatenated with this dot color concatenated with checker, period. Okay, so little display method that for a red checker will say a red checker, for a black checker will say a black checker. Save that, go back to our driver, c1.display, c2.display, and we'll see that we can now print out our 2 checkers. a red checker, and a black checker. All right. Now, let's say that we want to know whether a red checker was the same color as a, well, we want to know if C1 and C2 are the same color. How would I ask that question? So I'm asking, is C1 a red checker and is C2 a red checker? And is C1 a black checker and C2 is a black checker? How do I ask an individual checker what color it is? Here's what our checker looks like. Short answer is, I can't. I have no way of getting the color of a checker. So I'd have to give myself a getter. So public get color, return this dot color. So now I can ask a checker what its color is. Correct? Okay. So how do I ask if C1 and C2 are the same color? What would that if statement look like? Somebody give me a quick guess. A time crunch here. All right, I'm going to give the stupid guess. C1 equal C2. So we'll start with that. What question am I asking right here? Okay, what is C1? What is C1? I'm asking that. What is C1 right here? What you said is your answer is correct. Now I'm asking a follow-up question, asking you what is C1? It's a checker. What kind of value does C1 hold? If I were to print out C1, if I were to say system.out.println C1, what would it print out? Print out a memory address. Okay? So I'm asking here if C1 and C2 have the same memory address. And they won't because they were created with different real estate agents. Make sense? So this will never be true. So I will always print out not the same color in this case. Yep. This guy returns a string. Okay. So this will always print out not the same color. The only way it won't print out not the same color is if I say C1 equal to C1. Because those guys indeed are the same pointer. They are the same memory address. So then I'll get, yeah, those guys are the same color. Make sense? Saw that. It was a head bob, wasn't it?
Looking at me?
Huh? I wasn't even, I was like looking out here and I saw her going, there was enough movement. That's how bad it was actually.
Someone needs more coffee.
So what might the next upgrade be? The next upgrade might be C1.getColor equal to C2.getColor. And I'm actually going to create a C3 that has the color red. Okay. Is C1's color the same as C2's color? Not the same color. Is C1's color the same color as C3's color? Same color. But there's more than meets the eye here. If I do that, we'll do it on both of them. We don't need two. Is C1's color the same as C3's color? What's it going to print out? Not the same color. Why? It's actually an interesting truth about Java that kind of brings everything in the course together. What does the new keyword do? Finds us a memory address, right? So I'm finding one memory address here, and I'm finding another memory address here to put the string red. This is the equivalence operator for primitive types. What's a primitive type? Built-in type that can only hold a single value. Examples of primitive types are ints, chars, booleans, and pointers. Pointers are primitive types. It's a primitive type variable capable of holding a memory address. But remember, all the books say they don't exist in Java. Okay? But trust me, a pointer is a primitive type, even though you can't create one. So this guy is saying, is this pointer, the pointer that points to that string, the same as this pointer, the pointer that points to that string? That's what it's asking. It worked before when I just said red. But it doesn't work now when I said give me a string called red and a new memory address, and give me another string called red and a new memory address. Why is that? Well, when I explicitly call the new keyword, I'm saying go find memory for this guy. When I explicitly call the new keyword, I'm saying go find memory for this guy. Those are guaranteed to give me two different memory addresses, which is why this failed. This wouldn't have failed if I would have used the strings.equals method, because that compares the contents of a string, not the pointer of the string. Okay? The string has an equals method that knows how to compare two strings to each other in terms of their contents, not do they live in the same place in memory. But when I had it like this, it worked. Way back when we first looked at strings, I called this syntactic sugar. I said, Java gives us the ability, since strings are so important in Java, we have the ability to create strings on the fly, right? Well, this thinks they're the same color, even though we know they're objects. Is that a true statement? Red equal to red?
Yes.
Sure seems true. Is that a true statement? But won't S boil down to red? And won't S2 boil down to red? They're at different memory addresses. They will boil down to the same values, but their value themselves. S's value is a memory address. S's 2 value is a memory address, and they're different memory addresses. What about this? Will those guys be the same? Is that a true statement? It is. It is a true statement, which means that they hold the same memory address, correct? So why is that? This guy is a string literal. This guy is a string literal. A literal is a hard-coded value. For instance, 5 equal 5. That's a literal, correct? Int A equal 5, int B equal 5. A equal B, we expect that to be true, don't we? The real question is why is it true? Java will always use your computer's memory in order to resolve a variable. Even though primitive types like ints, we think of them as holding a value, they always hold a pointer. Okay, and we talked about this. When I said that all the books say pointers don't exist in Java, it's because there isn't a specific syntax. Everything in Java is a pointer. So now if you are in charge of remembering a number, if I say remember the number 5, and then I say remember the number 5 again, do you create a second memory location for 5? Or do you know about 5 and it exists one in your brain, and anytime somebody refers to 5, you refer back to that one place? If you need to remember something 10,000 times, but it's the same something, it's much more efficient to store it in one place and have everything point to that one place. So the literal 5 will be stored in one place in memory. The literal red, the first time it's used, will be created in memory, and first time it's used will be created in memory. The next time it's used, before it creates a new location, it'll check to see if that literal is already in memory. And if it is, it'll just point to the same place it used to point to. That make sense? Okay, so idea here is that there is a distinct difference between when we explicitly call the new keyword and when we use literals of any kind. Two literals that look the same will always be the same. But the double equal sign always compares memory addresses. Does that make sense? Okay, so that's kind of a quick and dirty way we can compare checker colors. I want to show you one last thing. Do I have? I really don't have time to show you this last thing. I think that'll be a first class next semester thing for that. So let's talk about the final for a minute. So if you want to see something really cool, come back for the first class next semester in the 300 class. If you're not already registered for 300, you should register for it because it's only offered in the spring. So if you don't register this one, you're going to miss it for a year. And then you won't have the prerequisite for your other classes. Anyways, final exam. Our final exam in here is what day?
Tuesday.
Tuesday at 10:10?
Yep.
Okay. So I'm going to design the final exam to take about an hour. You'll have the full hour and 50 minutes to work on it because they're 2-hour exams. So it should not be a time stress issue for you. Okay. You can use your notes. Okay, if your notes are on a laptop or something like that, I'm fine with that, but you cannot test code. So if you're going to bring a laptop to reference your notes, that's fine. Just promise me you won't use Eclipse and you won't use Google. Okay, use it for reading your notes. Just don't cheat. Okay, let's save a couple of trees and not force you to print out a book of notes. So anyways, you can use your notes. The test will be all short answer, fill in the blank, and programming. Well, really, all short answer and programming. No fill in the blank. No multiple choice, nothing like that. Go ahead.
What if you happen to write your notes on Eclipse in comments?
Basically, just don't cheat. So don't hit play. Okay. I'm not going to walk around. I mean, you're only cheating yourself. So if your notes are in Eclipse, that's fine. Just don't hit play. Don't test code. I'm fine with that. My expectation for a written test is that it might not be syntactically perfect. My expectation is I want to see what you understand. I don't want you, first of all, waste time with trial and error in Eclipse until you finally get something, and then all of a sudden you can't finish your exam. Okay, so just don't cheat, and if you can look at yourself in the mirror and say you didn't cheat, then I'm fine with that. Okay, the test will probably be half programming and half short answer. So concepts will cover half of it, and the rest of it will be programming questions, ranging from simple questions, write a method to do something, write a method to do something else, which shows your understanding of some of the different topics we've talked about in here. And if I have a more complex question, it'll probably just be one, where I ask you to maybe create a class that has a couple of methods in it and use those methods in terms of each other. So most of the programming questions will be write a method that does this, write a method that does that. That makes sense? All right, questions, comments, concerns, bribes. My grad students have been bringing me chili dogs and Italian beefs from Chicago, and that seems to be working. All right, I'll see everybody on Tuesday.